Hi everyone, the following is a video tutorial for how to complete our Simple Machines Investigation Lab with Onshape, specifically starting with lever systems. All right, so we're going to build out first, second, and third class lever examples using Onshape and some Vex Robotics parts. To begin, there is a link here on the daily schedule to log in to the Glenbrook Enterprise. Very, very important that you do that every single time you want to start building something out or modeling something with Onshape. Please use the enterprise. So when I click on this link, you'll see it'll take you to glenbrook225.onshape.com. When you follow that link, that'll bring you to the enterprise login portal. If you were just to go to onshape.com on your own and try to log in, it would work, but that's going to end up being your own private account, your own private side of Onshape. So please bookmark this. That way you don't have to come back to the daily schedule every time you need it. Bookmark it, add it to your browser links up here at the top of your screen, because you want to access Onshape through this link every single time. When I click on there right now, it's actually going to redirect me directly in because I already have some tabs open. And I wouldn't like to start over with that. So in any case, when you click on that link and you get logged in, then your landing page should look like this. You'll be on the Documents tab. And so here you can see all of my files, all of my organization, all the different folders I've created for student work. And then this is the lab that we're actually going to be starting with today. So Levers Simple Machines Lab. And if I click on that, there's just a project folder. I actually ended up sharing this file with you all. So it should be in your shared with me section. But what you'd like to do, or what I need you to do, is right click on that start file and click copy workspace. Okay. When you click on that copy workspace, take out the portion that gets added where it just says dash copy. And at the beginning, you could please put your full name, first and last, dash space again. So mine's going to say Justin Zumo, Levers Simple Machines Lab. Click open. And that takes a minute to populate. While that's going, I can show you the other tabs that I have open here. This is what that file is going to look like. So I'll have my version of that open here in just a second. And then here's a completed version of that file. All right, so this is ultimately what your example should look like, or pretty close to it. And I already went through and kind of picked out all the different Vex Robotics parts that you would normally want to use to build something like this in real life. The only thing I'm leaving out are the screws and the hex nuts, just because that's a little excessive for like a virtual kind of rendition of this. If you wanted to add those, you certainly can. You'll find all of that type of info along the bottom here. So there are separate part studios, separate assemblies. I actually have one giant file with all the Vex Robotics parts in it. And what I've done is I've went through and kind of removed things that you guys might not need for each file, for each lab, just to kind of clean things up and allow them to run a little faster, a little smoother. Otherwise, they kind of get a little laggy depending on how much things you have in there. This is a web-based application, so your computer, the device that you're using, and your internet connection will play a large role in how smooth this all works out for you. But in any case, this is my finished example. So the first one here is a first class lever. And I have a second class lever because the fulcrum's on one end, resistance in the middle, effort on the outside. And then a third class lever here, axle on one end, effort in the middle, resistance on the outside. And so you guys can build something very similar to this, if not identical, by following the series of steps that I'm going to lay out for you here. Before I leave my finished example, just want to show off a few things over here. So initially what I did to get going is, and I'll revisit all this here in just a moment with you folks. Scroll up my list here. This metal plate will be the very first thing that we drop in, and I've actually fixed it into position. That's what this little icon is for. So it fixes the metal plate, and I did that right off the origin, so like the 00 location for this assembly file, and everything else gets assembled and constrained to that metal plate. And so I ended up taking one of these metal gearboxes, and inside of there, kind of hard to see on that first one, there's a bearing block down here on top of that gearbox. And I also then fed the shaft through there. And those were the first three things that I assembled and attached to the metal plate for my very first example here. And I ended up linear patterning those three components, the gearbox, the bearing, block and the axle shaft. And by doing that, that allowed me to only need one revolute constraint, which is actually going to allow us to create an animation from this. And so I suggest you guys do that too. And I'll repeat that process, of course. So I'll show you how to make a linear pattern, but duplicate those extra pieces. And you do that because now I only need this one revolute. And if I go to animate that one revolute, since they're all patterned off of each other, it'll end up rotating all three lever systems at once. And so for you guys, your finished product from this lab will be something like this, where you're animating it, and then you use Screencastify to record your screen and just show us the animation, kind of talk us through the process that you went through, and then you can turn those videos in on Google Classroom for credit. All right, so we'll come back to this at the end of the tutorial, and I'll show you how to get to this point from start to finish. But this is the end goal. Just wanted to show you this first before we start building one out on our own. So if I go back here now, this is the file that I made a copy of, has my name out in front of it. And again, bunch of different tabs across the bottom here with different Vex Robotics parts. So if you try to click through those, you can see what they've done. In Onshape, these are called part studios. These are where you can actually model your parts, do sketching and extrusions and revolutions and all that great stuff. But what I've noticed is people use part studios as a spot to hold all types of parts of similar categories. So for example, this one part studio has 10 different parts on there, and they're all different types of gears that we have access to with Vex Robotics. So in my opinion, I would just do single part studios for single parts. I don't like that they're all kind of in the same space here. You could turn the visibility off for them and kind of reduce it down to just one part in the studio, which I don't know. It's a little against my own thinking for how to put things together. But when you actually go to create the assembly then and place parts from each of those part studios, I'll just give you a quick look at what that looks like. I've already laid out all the parts that you're going to need, but just so you can see what that looks like, if I go to insert parts, you'll see the axles category, for example, and there's an arrow next to it. So if I click that arrow, it'll then reveal to me each of those different axle shafts that we have in the program here. All right, so same thing, if I scroll down a little more, find the gears, you see all the individual gears. So this is why they build it out the way that they do. So when you open something, you get this nice drop-down list. You can see all your options then. But I would probably just do single part studios for each part, but that's okay. Okay, so here we are. We're on our first assembly tab. Again, all the parts you're going to need to build the example are here. And just to show you a few bells and whistles here, we have a view cube, just like we did in Autodesk Inventor. So you can still manipulate around the assembly by clicking on different corners of the view cube. You can also just click on the screen and rotate it. That's usually what I do. So I'm just using my trackpad on my laptop here, and I have 3 buttons on my trackpad, a left, a middle, and a right. And if I click on my right button, this allows me to rotate around the screen. If I click on my center button, it allows me to pan back and forth. And then if I click on my left button, this is my selection. So I can either click and drag a big box to select a bunch of things all at once, or I can just click on them individually by left clicking and select them like that as well. Okay, so that's how we kind of navigate the workspace, view cube, and the buttons on the mouse, on the trackpad. Over here on the left, you have all of the different things that are inserted into the assembly already, which is nice, kind of like our history. So you can go back and see these parts, modify them, turn them on and off, do whatever you need to do with that. And then once we get down to making our constraints, you're going to see all of those start to populate towards the bottom of this list down here where it says Make Features. And then that brings us to these different tools along the toolbar at the top here. So this first category is used for actually constraining these parts together, and it's very different than what we used to do with Autodesk Inventor. And I actually like it a lot more for that reason, because it's different. In Autodesk Inventor, we would have to do 3 separate constraints per part to kind of lock it into position and to take care of all 3 degrees of freedom. Well, here in Onshape, it's just 1 constraint per part, and it'll lock it in all three directions for you. So very nice. Let's say 90%, maybe 95% of all the constraints you're going to do in this lab are going to be a fastened mate. So this very first option. And then as I showed you on the completed example, we'll have one revolute mate, and then you'll pattern that so it'll control all three lever systems at one time. We'll get down to touching some of these other ones in further labs. And then scrolling down the list here, here's linear pattern. We'll use that to create those two other instances, as I mentioned. There's also some things in here about gear relation and rack and pinion relation, screw relation. We will get to all of those a little bit later on in our upcoming labs. So let's go ahead and begin. I'm going to set up one of these mounting brackets first and get that placed into position here on my metal plate. So I did mention the metal plate is already fixed into position for you guys. It says it right here, part is fixed. So it's not moving anywhere. Everything else can just get constrained directly to that plate or to the parts that are already attached to the plate, however you want to do that. So I'm going to click on Fasten Mate to get started. And another thing I like about this assembly constraints here in Onshape is when you start to then move over to your part with your mouse, you'll see all these different nodes start to pop up. I think that's extremely helpful. So I can click on any one of these points and use that as a point of contact for my fasten constraint. What I'm actually going to do is select the midpoint of this very thin edge here on top. And so if I just move my mouse out of the way for a second, you'll see right in the dead center there's a black and white symbol. It's actually called a centroid. We will learn about centroids a little bit later on this year, but a centroid is like the center of mass or the center of gravity for a shape or for a surface or for an object. And so here it's telling us that's the dead center of that very long rectangle. So I want to click on that first. And then if I move over to my metal plate here, zoom out, find it, here we go. I can click anywhere on here to get this thing mounted into place, but I am going to pick one of my middle points here. And just to pay attention to what it's presenting to you. So I want like a flat one here. You noticed a second ago, I kind of went to the line. It probably won't come up again. Okay, well, either way, I just want my symbol to be flat on the metal sheet. So then when I click there, it brings those two pieces of metal together. You can tell it's upside down right now. And so there are some ways to modify this constraint then. I first want to flip it so that it comes back up top. And then just to kind of go with the example that I had already figured out, I would like to rotate this then. So if I want to rotate, I have to check the box for offset. And then I can specify rotate around a specific axis. For this, I'm going to rotate around the Z. And I'm going to do it by 90 degrees. So I just click inside the box there so that my mouse is not inside there adding the number. When I click that, it solidifies that. It rotated it. It looks perfect. I'm going to hit the green check mark to finish that constraint. And so again, that was just one fastened constraint. And if I try to move this piece around, it doesn't go anywhere. It is locked in against this other sheet of metal. Now in real life, this wouldn't work, right? We would need some type of bracket or something to make the transition between those two pieces of metal and to fasten it all together. But for our purposes here today, this will be just fine. So I have that gearbox bracket attached in the center down to the left here. So I have room for my other two examples. And now I want to get this bearing block set into position right up top. The bearing block has two mounting holes, and there are 4 mounting hole options here on this. So I'm just going to kind of center it to the left a little bit. Let's go ahead and do a fastened mate. This time I'll go to the gearbox first. Doesn't matter what order you go in. So I'm going to grab the center point here for my first hole. And then if I scooch over, I'm going to rotate because I want to grab the bottom. And I want to find the center of this hole right there. Boom. Click it. Zoom back out. See what the result gave us. Pardon me. I meant to just pan the screen there so I could see that better. Okay, so again, it flipped to the inside. So I'm just going to click Flip Primary Axis. It pops it to the outside. And it actually is in perfect rotation. So there's nothing else for me to do there. I'll just hit the check mark. Now that is set in position. Okay, so one more thing that we can do here is actually add the axle shaft. And I'm going to put that directly inside the hole here on this bearing block. And again, there is more than one way that you can create these assemblies, but this is the option that I'm choosing to use and to share with you guys. So for this, I want this axle shaft to rotate, right, as the levers rotate. So I'm going to do a revolute mate on this axle shaft here. And I'm just going to pick the endpoint. If you're patient enough, you can get like the dead center of that to kind of show up. I think I saw it there for a second. But I'm just going to go ahead and grab the endpoint here, and then I can offset it into position to kind of get it squared up nicely and centered nicely. I lost my rotation here. So I'm just going to go back to my perfect isometric view and zoom in on this bearing block. You can see here I made a mistake. And again, I selected this edge, which is on a slant. I forgot. And so the axle shafts actually went on a slant too. So to fix that, I go back to my revolute constraint, delete the selection I had made from before. And then I actually want to grab the inside center of that hole. Well, I wonder if I'm even able to do that here. Yes, I got it. Okay, so instead of grabbing the outside of that hole, you want to move over to the inside. And you can see right when I made that selection, my shaft straightened out here. And if I go to my right side view, that also got repeated into my other examples. So sorry about that mistake there, but you live and you learn, and that's part of our process here as we're learning, right? So again, do not click the outside surface of your bearing block. Make sure you find that node in the center of it so that it's not on an angle and the shafts go in nice and straight. So you should be able to click on that axle shaft and rotate it inside the hole, but it shouldn't go anywhere else. It should just be able to rotate, and everything else should be kind of cemented and fixed and fastened into position now. All right, so we got those three parts assembled to our plate. From here, we can cheat a little bit and do it in a linear pattern, duplicate those bases. And as I said in my finished example, that means we can animate all three of these examples with just that one revolute constraint now. So I'm going to go to assembly pattern. And what we want to do is select the instances to pattern. So I want 1, 2, 3, all three of those parts. And then I just have to click on the direction box here and tell it what direction to go in. Anything will do. I'm just going to select the side piece here to send it in that direction. And then you get to set the distance and how many. I want 3 of them ultimately. So I'll change that to 3. And then I'll just type in a number that gives a little bit of space in between each of these and doesn't allow it to fall off the plate or something. So I'm going to go with 4 inches, 3 instance counts, hit the check mark. And again, if I try to rotate my one axle shaft, all 3 of them are rotating now. Okay, so that was the base and getting all of that set up. Now we just want to go ahead and add some of these bearing flats to our C channels here, which are going to act as our levers that we drop on top. All right, now bearing flats very important because this is going to make a rounded hole support for the axle shaft, just like there was a rounded hole here on the bearing block. And again, very important because all of our axle shafts are square and all the holes on our metal are also square. So a square inside of a square doesn't really rotate very well, very clunky, a lot of friction loss there. So we put these bearing blocks on there just to give it a nice plastic rounded hole to rotate inside of, and it's working out a lot better. So I'm going to get 2 of those mounted directly center on the C channel to create my first class lever example. So let's go ahead and do that. I'll pull up a fastened mate. And it doesn't matter which hole you pick, I'll just go with this one. And then on the C channel, there are 5 holes here. I want that to be dead center. Since I picked one off to the side, I'll go one over to the left. And I want this inside edge. I think I might have to rotate slightly so I can get that to pop up. There we go, right in the center. Boom, it's flipped. So I'll just hit the flip arrow and then it's in perfect rotation there. So that's good. I'll hit the check mark. We'll do that one more time. I'll get one more of those put in there. See one over here I can grab. Grab one of those, come back. rotate a bit, zoom in. I'm going to grab this one. Excellent. Just need to flip it and I need to rotate it. So I'll go to offset, rotate around. I think I want to rotate around the Z on this one. 180 degrees. Perfect. Green check mark. That's in position. So now I can take this and land it right onto the axle shaft with a fastened constraint. Okay, now let's try this again. Do another fastened mate. And I want to grab this piece here. And on my axle shaft, I'll grab the outside. And as I was saying before, just play the offset game, get that put into position. So bring up offset, type in a value. Let's try 0.65 and see where that puts us. Hit check mark. Actually went in the opposite direction. That's always fun. So let's go back here to that constraint and type negative instead. And negative 0.6. Let's see where that puts us. A little too far. Just playing the guessing game here. Negative 0.5. 0.5. And I can still bring it down a little more. So let's try that one more time. Negative 0.4. That looks about right. And if I just rotate to the side here, I can see, ooh, I like this a lot. There's just about a perfect amount of distance between the bearing blocks and the bearing flats. Shaft fits all the way through, and it might not be perfect. There might be a little intersection between plastic pieces and metal pieces, but for our examples and the purposes of this lab, this will be perfectly fine. Okay, so I got my one lever on there. Whew, that took some work. And what you guys will notice then is you're not going to need these additional components since we did the linear pattern. So you can play cleanup a little bit if you want and delete some of these things out. All right, not going to need these, not going to need these. Already got all the shafts we need. Okay, so from here, you'd want to repeat this process, continue assembling these bearing flats to the metal pieces here, and create a second and third class example. And then the last thing that we can do is mount our arrows onto it, and that'll be real simple too. You just do a fastened constraint between the tip of the arrow and the center of a hole here on one of the metal pieces. And again, this will allow you to rotate one of them and have all of those shafts rotating. All right, and you can see here that it'll rotate 360 degrees unless you actually tell it to be constrained within a certain limit. And so when you go to animate, that's where you can tell it to just do, if I go to animate here, you can tell it to go between 25 degrees and negative 25 degrees. Maybe bring steps down to like 50 or something. And then if I hit play, it'll kind of just seesaw back and forth there. So this is ultimately what I'd like you guys to do, as I said before, is you'll have a finished example like this. When you animate one of them, all three of them are animating along with that. Record this as your video and submit it to Google Classroom. Hopefully you enjoy getting started with Onshape here and building out our lever examples and simple machines. So thanks for joining me today, everybody. This was a quick look at how to create first class, second class, and third class lever examples using Onshape and Vex Robotics parts. Please record this video of your animation using Screencastify and submit that to Google Classroom. Thanks for tuning in. See you next time.